afternoon and good evening and welcome to today's webinar. My name is Tanya Budgell and I'm going to take you through a little bit of platform housekeeping before we get into our webinar. Things you need to know. At the top left-hand side of the platform, you're going to find the speakers button. This is where you can learn everything about our subject experts on today's call. On the right side panel, you will see polling. We will be distributing polling throughout today's session. Please participate in as many as you can so we can collect that information. And under the docs section, you will find a number of resources that will be helpful in today's webinar. We will be using the Q&A, so any of those questions that you have, submit underneath the Q&A and we will address them during today's webinar. If by chance we don't get to all questions, we will respond to them after the webinar. And over to you.
Thank you, Tanya. Welcome everyone to this webinar presented by IEG, which is International Aerospace Environmental Group, continuing our training on materials and substances declaration development. That's based on our guidance document created to aid original equipment manufacturers, or OEMs, and the aerospace and defense supply chain in developing clear and accurate materials and substances declarations. And please note that this webinar is being provided in good faith for informational purposes only and is based on the best available information. It is to be relied upon at the user's own risk. IEG and the authors and presenters of this material make no representations or warranties with regard to its completeness, and no liability will be accepted for damages of any nature whatsoever resulting from the use of our reliance on the information included. No part of this webinar constitutes legal advice. And my name is Allie Rains. I will be moderating today's webinar. I'm a client support assistant with Haley & Aldrich, a consulting firm that focuses on environmental compliance, as well as management consulting and geotechnical engineering. We have been liaison members with IEG since 2019, and I assist Workgroup 1, who is presenting this webinar, with management and coordination of various sub-team related projects, in addition to administrative oversight and work products. And Lucy Reinbold is an engineering lead within the Global Chemical Substances Program at Raytheon Technologies. She is the leader of the sub-team, and within Raytheon, she leads the chemical regulatory compliance and risk management activities. She also chairs the Sustainable Engineering and Design Technology Interest Group at Raytheon. Lucy has a Bachelor of Science, a Master of Science, and a PhD in Materials Engineering from Brown University in Rhode Island. He is the deputy of the Materials and Substances Declaration Work Group, which is Workgroup 1 within IEG, and leads the Declaration Development Support Team. Our question and answer panel, Jimmy Veslin. He's a development engineer and environmental coordinator of business area dynamics for Saab. We've got Mr. Rick Shanks, engineering manager and global chemicals program at Pratt & Whitney. Tim Sheehan, engineering fellow, global chemical substances program with Raytheon. We've got Valerie Kuntz, who's regulatory and sustainability expert for product sustainability within Ascent. Lucia Pietros, our senior sourcing manager with GE Aerospace. And of course, Dr. Lucine Reinbold. Now to introduce IEG. IEG is a forum where unprecedented collaboration can take place among leading aerospace and defense companies. Our focus is on addressing relevant issues related to climate change, to lead the way on chemical stewardship, engaging our vast and global supply chain to drive improvements on global environmental and sustainability issues facing the aerospace and defense industry. We do that by developing effective solutions, taking all of the aerospace and defense industry value chain into consideration to ensure that our industry remains responsible and sustainable for the future. Our products are unique in that they are very complex and expected to be in service for multiple decades. IEG celebrated its 10th year in 2021 It was founded in 2011 with 11 founding companies, all within the aerospace and defense industry. Today, IEG has nearly 50 companies, representing over 50% of the total global aerospace industry's annual revenue. So to learn more about IEG and the work that we do on behalf of the aerospace and defense industry, please explore our website. Our work groups are doing very impactful work. You can also find us on LinkedIn, where we regularly post news and communications weekly from within our organization. Now about Work Group 1, the Materials and Substances Declarations Group. Work Group 1 within IEG is chartered with establishing a standardized process for collecting information on chemicals contained in mixtures, materials, products, and/or articles, and technologies to proactively respond to required reporting to customers or regulators. And that's in order to achieve compliance while preventing business interruption. One of the primary focuses within our work group is to generate support documentation that will promote consistency, quality, and efficiency of material and substance declaration data gathering. So to that end, Work Group 1 recently published a very comprehensive and helpful declaration development document. It's called the Materials and Substances Declaration Development Document. And it's on our website, available to the public free for download. And with that, I will invite Lucy Reinbold to present our next slides on the development process.
Thank you, Ali. Welcome to all our webinar viewers today. Did you know that elemental chromium present in a metal alloy does not have the same environmental and health concerns as chromium present in hexavalent chromium compounds? Did you know that anodized aluminum is often subsequently sealed, and the anodized seal itself may contain declarable substances such as hexavalent chromium compounds? Did you know that safety data sheets created for certain jurisdictions or countries may differ in their reporting of substances than those from other geographical locations? Did you know that safety data sheets often list volatile or evaporative substances that should not be used to calculate and report article declarable substance mass content? After viewing this webinar, we hope you'll have a better understanding of these and many other issues and challenges encountered when working to develop accurate materials and substances declarations. Today during the webinar, we'll set the stage by reviewing the purpose and benefit of generating clear and accurate materials and substances declarations. We will then review some of the challenges encountered during the declaration development process, including those related to safety data sheets, volatile and processed substances, and transformational and reactive substances. Next, the declaration process steps will be discussed and illustrated with a flowchart, and a couple of examples will be presented to highlight how one navigates through the declaration process steps in order to identify and calculate mass for any declarable substances. Lastly, some helpful resources and support tools will be identified so that webinar viewers can obtain more detailed information on the declaration development process. So first, we will set the stage for why it is important to develop meaningful materials and substances declarations and how they can vary in complexity depending on where within the supply chain an article or product producer resides. Due to the constantly evolving regulatory requirements around the world, coupled with company-specific requirements and the global nature of supply chains, it is more important than ever to be able to generate accurate and compliant materials and substances declarations to provide critical information on product content. This helps facilitate effective data exchange with respect to safe use and product disposal information, as well as risk management efforts. Products within the aerospace and defense supply chain can range in levels of complexity. This image, taken from the Aerospace and Defense Industries Association of Europe's sectoral guidance for substances and articles under REACH, illustrates just how complex a product such as a commercial aircraft could be, as it is comprised of hundreds of thousands of individual piece parts at various layers of the product assembly. Regardless of the complexity of a product, however, the same general steps would be taken when developing a materials and substances declaration. To further illustrate an example of a complex product, though less so than a commercial aircraft, an LED lamp panel lamp is shown here to contain articles or lowest level parts, such as an LED module, thermal transfer pad, a heatsink, a base, and a socket. It also contains a subassembly driver, which itself contains its own lower level parts or articles, such as a capacitor, an LED integrated circuit, a resistor, and a printed circuit board. Each of these 9 lowest level parts shown in red contain their constituent materials and substances that must be reviewed by the LED lamp manufacturer in order to determine what is to be declared. Substance declarations occur at this article level within a complex product or assembly. This helpful illustration can be found in IAEG's recently published Materials and Substances Declaration Development document on our website. So now it is time for our first quiz question. True or false, when you have a product or assembly that contains multiple parts or subassemblies within it, substance mass is calculated and reported at the top assembly or product level. We'll go ahead and open up that poll question. So go ahead and take a minute. You have a 50-50 chance of getting this right. I'll just give everyone a couple more moments. All right. I think we'll go ahead and close the poll and see how everyone did. I apologize for the lag. So the answer is false. Substance mass is reported at the lowest piece part or article level, i.e. the lowest level part on a bill of materials. So the declaration process involves the following steps. First, identify the applicable declarable substance list that the declaration requester has identified. Identify the product or products that require a declaration. Next, determine if the product is composed of any subassemblies using the bill of materials, engineering documentation, or other logical product structure. Identify all materials in the product, including within any subassemblies or articles that make up the completed product. Identify the substances present in all the materials. Compare the list of substances against the declarable substance list and determine if any of these substances must be declared. If there are none, report that there are no declarable substances in the product. If all options to determine the substances in any of the materials have been exhausted with no success, declare that substances are unknown. Next, we must determine if substance mass reporting is required. If not, then simply declare the presence of the declarable substances without their quantities. If substance mass is required, steps are then taken to calculate these values. And lastly, the presence and quantities of any declarable substances are reported. This flowchart shows a high-level representation of the typical process a supplier might follow upon receiving a declaration request. Later in the webinar, we will review a couple of examples that navigate the user step by step through this declaration process. So we will now highlight a few of the challenges that are faced when trying to identify declarable materials and substances present in a completed product or assembly. First, caution should be used when referencing a safety data sheet or SDS to determine the presence of substances in the finished product. For example, the SDS may not indicate all substances contained in the material. For example, some may be proprietary or exempted from disclosure requirements. Further, it should be noted that SDSs created for certain jurisdictions or countries may differ in their reporting of substances than those from other geographical locations. For example, An EU SDS may report certain substances that are only of concern within the European Union, whereas a US version of the same SDS may not report those same substances if they are not considered hazardous in the United States. An SDS may not indicate the substances formed from chemical reactions during processing. An SDS may not indicate substances that are lost or consumed during production, such as those that are volatile or reactive. Or an SDS may not indicate substances present but below an applicable regulatory concentration threshold. For example, less than 1% for non-carcinogenic substances in the US. It's also important to note that in different jurisdictions, substances may be referred to by different names or even CAS numbers. Here we show an example of 4 safety data sheets for the same exact product, a thread sealing compound. What you might not realize is that depending on which country or region's SDS you look at, you may see a different list of substances reported. For this specific example, you can see that the US and Canada safety data sheets show 1 or 2 substances totaling 5% or less of the total material composition. Meanwhile, the European Union's SDS lists 3 hazardous substances, while the South Korea safety data sheet discloses 7 different substances and CAS numbers, several of which do not appear on the other 3 safety data sheets. This is a clear example of how SDSs for different regions may differ dramatically, depending on the local regulatory reporting requirements. One should also pay close attention to the date of the safety data sheet, as they are typically updated over time and may disclose different substances between one iteration and the next. And we have now gotten to quiz question number 2. So this is multiple choice. Which of the following statements are true about safety data sheets? A, they always include every substance present in the material. B, they may disclose different substances depending on the country or area of jurisdiction. C, they never report substances that are volatile or evaporate during processing. Or D, substances always have the same name and CAS number on all SDSs regardless of jurisdiction. I'll go ahead and give everyone a minute or so to pick the right answer. All right, I see a lot of votes are showing up for option B. We'll give everyone another moment or so. And I think we can go ahead and close the poll and see how everyone did. All right. All right, let's click. So the answer in this case was B. It looks like everyone did pretty well. Safety data sheets may disclose different substances depending on the country or area of jurisdiction. So the volatility of a substance is a measure of its tendency to vaporize into the air. To estimate the chemical content of products and components, it is important to consider volatility to determine which substances may have evaporated from product surfaces and use that information to properly estimate the concentrations of remaining substances. Many substances used as solvents to develop products are volatile, for example, acetone or toluene, and their loss to the air must be accounted for, and their presence should not normally be reported as a chemical constituent of a finished article. In fact, many substances used in chemical formulations, for example, organic solvents or water, are intended to readily vaporize under processing conditions. When uncertain about substance volatility, consultation with the manufacturer or supplier could be helpful. Processed substances are typically chemical products that are applied in one or more process steps during the manufacturing of an article. Common applications for processed chemicals throughout manufacturing can include preparation of a surface for future processing, for example, cleaning and degreasing fluids, or modification of one or more properties of the surface of the article. Solvent, mechanical, or chemical cleaning of surfaces is not expected to leave a substance from the cleaning process on the surface of the product as delivered. Substances in etchants, deoxidizers, and pickling chemical processes are not intended to remain on the metal surface after chemical processing is completed. Metals may have surface treatment applied to enhance performance, such as by improving corrosion resistance. A surface treatment may be composed of multiple layers of materials, and substances in all layers must be identified. Refer to the coating specification to identify the layers and material content. Common metal alloys and their surface treatments, including anodization and conversion coating of aluminum, passivation of corrosion-resistant steel, and plating of metal surfaces. So now we are at quiz question number 3. This is a true or false. Volatile substances, or those that typically evaporate under normal conditions, should be reported on a materials and substances declaration. We'll open that poll. So go ahead and vote true or false. We'll give another moment or so. All right, I think we can go ahead and close this poll and go see how everyone did. All right, in this case, the answer was false. Substances that readily vaporize or evaporate under normal conditions are not expected to remain on a finished product and therefore are not normally reported as a chemical constituent of an article. The use of transformational materials complicates the determination of which substances remain on the as-delivered article. Examples of materials or mixtures that contain transformational substances include primers, paints, sealants, and adhesives, to name a few. When determining the amount of a substance that is present in the final article, particularly in the case of paints, it is necessary to consider that the concentration of the substance usually increases in the reaction product or mixture due to solvent evaporation, while the paint pigments and solids remain on the finished article. In contrast, substances and sealants normally do not change much in weight, while adhesives are so broad in possible behavior that a case-by-case approach must be applied. It is recommended as good practice to consult with a knowledgeable individual, such as the material manufacturer or formulator, a chemist, or a regulatory or engineering subject matter expert, prior to reporting potential volatile or reactive substances on a declaration. Materials that are stored or shipped in dry ice or controlled temperatures may also be reactive, in that the substances react and form different substances on the article as delivered. Examples of these types of reactive materials include structural adhesive film, pre-impregnated composites or prepregs, casting adhesives, filament winding materials, resin fusion materials, two-component systems such as coatings, adhesives, and sealants, frozen premix of multiple components that are sent by dry ice or controlled temperatures, and reactive hot melts. Material stabilizers, fillers, polymers, and flame retardants are expected to be present in the article as delivered. Materials such as hot melts that are simply heated and then cooled should not undergo a change in composition. And now we are at, I think, our last quiz question. So this is yet another true or false. Elemental chromium in metal alloys and plating has the same environmental and health concerns as chromium present in hexavalent chromium compounds and must therefore be declared as a hazardous substance. We'll open that poll and let everyone vote. All right, we see some folks are still voting. We'll give another moment. All right, I think we'll go ahead and close this poll now and see how everyone did. So our answer in this case is false. Elemental chromium in metal alloys and plating form do not have the same environmental and health concerns as chromium present in hexavalent chromium compounds. In other words, metal alloys may contain elemental chromium, but do not contain regulated hexavalent chromium compounds. Now we will walk through a couple of declaration process examples to highlight how to navigate the process flowchart step by step. For our first example, we will use a simple case of a single coating on a base material, a cadmium-plated steel nut. Step 1 is to identify the applicable declarable substances list, or DSL. In this case, we will pretend that a fictional request was received that asked us to provide a declaration against the Aerospace and Defense Declarable Substances List, or ADDSL. Step 2 is to identify the product or products. Here, we just have a hexagonal nut. Step 3 is to identify any subassemblies within the product. In this case, there are none. Step 4 is to identify all materials in the hexagonal nut. Here we have two materials. The substrate is made of low carbon steel, grade 2H per ASTM A194, and the plating material is cadmium per AMS QQP 416, type 2, class 2. Step 5 is to determine the substances present in each of those materials. The substrate ASTM A194 steel alloy grade 2H contains carbon, phosphorus, sulfur, silicon, and iron. The cadmium plating material obviously contains cadmium, but the type 2 specification within AMS QQP 416 means that the cadmium plating layer also has a supplemental surface treatment that contains hexavalent chromium compounds. Step 6 asks us if there are any declarable substances present in the materials, in this case, ADDSL declarable substances. The answer is yes, cadmium and hexavalent chromium must be declared for this part. Step 7 is asking if substance mass is required. In this case, yes, the fictional request has required us to declare substance masses. Therefore, in step 8, we must calculate and declare these substance masses. We will start by determining some basic parameters and properties that will be used in the substance mass calculations. We calculate or determine the surface area, volume, and density of the substrate. The published IAEG document on our website actually guides the reader through some examples of calculating surface area and volume of basic shapes. Using these values, we can then calculate the mass of the article or nut, which will be used shortly when we calculate the mass percent of each substance in the article. Next, we calculate the mass of our first declarable substance, in this case cadmium. The mass of cadmium in the nut is equal to the mass of cadmium in the coating, since cadmium is present only in the coating and not anywhere else in the article. The cadmium mass can then be calculated using the formula shown here, using the cadmium plating properties shown in the yellow table. One can also calculate and report the mass percent of cadmium in the finished article by dividing the mass of cadmium in the coating by the mass of the article, and this results in a value of 1.13% cadmium in the hexagonal nut. Next, we must calculate the mass of our second declarable substance, in this case, hexavalent chromium or chromium 6 oxide. The same calculation procedure is used as for the cadmium in the plating layer, only this time we use the properties for chromium oxide as shown in the yellow table. This results in a mass of 0.0000108 pounds, or 0.0355% chromium oxide in the hexagonal nut. The two substance mass values that we calculated for cadmium and chromium oxide would therefore be reported on our declaration for this nut. For our second example of navigating through the declaration process, we will look at a case with multiple coatings on a base material, a chromated and primed aluminum cover. As before, step 1 is to identify the applicable declarable substances list, or DSL. In this case, we will again pretend that a fictional request was received that asked us to provide a declaration against the ADDSL. Step 2 is to identify the product or products. Here we have just a cover that is primed on one side. Step 3 is to identify any subassemblies within the product. In this case, there are none. Step 4 is to identify all materials in the primed and chromated cover. First, the substrate itself is made of A357 aluminum. The first coating on the aluminum is Mil Detail 5541 Type 1 Class 1A chromate conversion coating. The second coating is Mil PRF 23377 Type 1 Class C2 strontium chromate-based corrosion inhibiting primer. Step 5 is to determine the substances present in each of the three materials. The substrate A357 aluminum alloy contains aluminum, silicon, beryllium, iron, copper, magnesium, titanium, zinc, and manganese. The Mil Detail 5541 Type 1 conversion coating contains hexavalent chromium compounds, while the Mil PRF 23377 Type 1 Class C2 primer contains strontium chromate and an epoxy polymer. For the purposes of this example, we will pretend the epoxy polymer is not listed on the DSL. Step 6 asks us if there are any declarable substances present in the materials, in this case, ADDSL declarable substances. The answer is yes, we have 3. Beryllium, hexavalent chromium, and strontium chromate must be declared for this part. Step 7 is asking if substance mass is required. In this case, yes, the fictional request has required us to declare substance masses. Therefore, in step 8, we must calculate and declare these 3 substance masses. As before, we start by determining some basic parameters and properties. We determine the surface area, volume, and density of the substrate. The first substance mass we need to calculate is beryllium in the aluminum substrate. A357 alloy contains a maximum 0.07% of mass by mass of beryllium. Therefore, in this case, we will use this maximum or worst case value of 0.07% for the beryllium. Next, we calculate the mass of the hexavalent chromium in the conversion coating layer. The hexavalent chromium mass can then be calculated using the formula shown here, using the conversion coating properties in the yellow table, and the result is 0.18 grams. One can also calculate and report the mass percent of hexavalent chromium in the finished article by dividing the mass of hexavalent chromium in the coating by the mass of the whole article, and this results in a value of 0.0138% hexavalent chromium in the chromated cover. Now we must calculate the mass of our third declarable substance, strontium chromate. The same calculation procedure is used as for the hexavalent chromium in the conversion coating layer, only this time we use the properties for strontium chromate as shown in the yellow table. This results in a mass of 1.3 grams, or 0.1% strontium chromate in the primed and chromated aluminum cover. The 3 substance mass values that we calculated for beryllium, hexavalent chromium, and strontium chromate would therefore be reported on our declaration for this article. As we begin to wrap up our webinar today, we will show you where to get more helpful information about the declaration development process. If you would like to see more detailed examples of substance mass calculations, please visit the IAEG website and download the free Materials and Substances Declaration Development document. In addition to the examples shown today, this valuable resource illustrates calculations of lead in solder, sodium dichromate sealing treatment on chromic acid anodized coatings, and various other examples. This IAEG publication also contains several helpful appendices such as this one that lists some common declarable substances used in aerospace and defense industry products. Another helpful appendix lists common surface finish specifications, including both military and industry specs. The final appendix of our Materials and Substances Declaration development document provides several website references and links to help the reader find information on common substrate materials such as copper, aluminum, and plastics. Various important regulatory and compliance websites and publications are also listed in this section. The link on this slide will take you directly to the Declaration Development Support resources on IAEG's website, where you can access and download this informative document. Over the coming months, the Declaration Development Support team at IAEG is working to add a few additional calculation examples to our document. These will include calculation of declarable substance masses in a jacketed and insulated standard aerospace and defense cable, as well as how to work through the declaration process for a small assembly of multiple articles joined by fasteners with an applied sealant material in the assembly. With that, I'll invite Ali back to the stage.
Thank you so much, Lucy. Right now, we'll invite our panelists to enter the stage, and we are ready for questions. Feel free to enter your questions in there. And with that, what I'll do is I'll get started with some questions that were asked pre-webinar. And Lucy, we're going to start off with a question for you. How do we declare proprietary information?
Thanks, Ali. Hopefully you can hear me. That's always a challenging issue. That is something that should usually be discussed or worked in a business-to-business kind of discussion. It's not always necessary to list out the entire composition, exactly percentage by percentage. Sometimes it's deemed to be sufficient just to declare if there are any specific declarable substances present in a proprietary material without having to disclose the entire composition.
And I'm going to add on to that. This is Valerie. If you do include anything that is proprietary, you must include anything that has to be disclosed, and then the remaining part can be continued to be proprietary. So that's the main thing. If you're dealing with a substance or a material that has something that needs to be declared, the remaining portions of it can be declared as proprietary, but you must declare anything that has to be declared per whatever regulation or substance list that you're working with.
Thank you both. Any other comments on that question from our panelists?
This is Tim. I would just again emphasize what the other two had said. It really depends on the requirement, right? So if you're required to disclose proprietary information, the contract that you have with as a declarant with your customer would really govern how that data should be provided.
Great. With that, I'm going to go to Valerie. There are two questions for you. What if I don't know the weight or concentration? What should I do?
So if you don't know the weight or the concentration, try and do your best to provide the information as much as possible, because the concentration obviously impacts the overall information that you have to be declared. But depending on which version of the declaration or whatever you are providing to your customer and what they're asking for, they may ask for the actual concentration. They may ask for as much information as possible. But in many cases, you are allowed to say, I don't know. And then the important part is I do have the substance. I believe it is above concentration, and those are the pieces that are most important for doing a declaration for a customer. Even if you don't know exactly what it is, still provide as much information as you can.
Thank you, Valerie. And how can we make the declaration process easier when it is proprietary information?
So when it is proprietary, obviously you're going to say it's proprietary or whatever. If you're doing a full material declaration, a full substance declaration within the IPC 1754 option, it does allow you to say, I don't have, or it is unknown for specifically there within that information, but you have to at least disclose or account for 100% of whatever the substances are. So even if you do say, I have proprietary information, or even if you're doing within the IPC 1752A, you have to at least say, this is proprietary, this I'm not telling you, but you have to account for that 100% to say, I'm not telling you everything, but I'm giving you as much information as I can.
Okay, thank you, Valerie. I'm going to go to a question for Lucy and Tim. Is there any advice when the customer is requesting substances used in process, even if not present in deliverable article? And I'm sorry, that question is for Lucy and for Tim.
Yeah, I'm sorry, Allie. Could you repeat that? My connection cut out.
Yes. Is there any advice when the customer is requesting substances used in process, even if not present in the deliverable article?
Well, again, it really would depend upon what is negotiated between the customer and their supplier. So if you're the supplier, you want to make sure that the scope of the declaration is really focused on the products, unless there is some compelling reason that's been agreed to that you would also declare the process materials that you use to make that product. So again, it really depends upon the requirement. If you can negotiate it with your customer that they need to have some information about the process chemicals you're using, then that needs to be within the scope of the agreement that you're providing that declaration under.
Okay. Lucy, did you have anything to add? I think you kind of covered that one, huh?
Activity issues also, but yes, Tim's answer was great.
Okay, and with that, I'm going to go to a question for Tim. Can companies in non-aerospace and defense industries use the information included in the document?
Yes, absolutely. In fact, that was correct me if I'm wrong, Lucy, that was the original intent of this.
Yes.
Of this whole activity.
Yes, this document was specifically written basically regulatory agnostic or even industry agnostic. It's literally just the whole process of creating an accurate declaration, regardless of who's doing it, regardless of which regulation you're reporting against. We have examples that are showcasing how to do an ADDSL declaration versus EU REACH and so forth. So the process is the same regardless of what type of industry company is having to provide this document and against which declarable substance list.
And the standard pitch that we've used in the past is that we would welcome other industries being involved in developing this information so that they are providing common information to their supply chains across many supply chains. So that would be a really interesting thing to have other industries work on this with aerospace and defense.
Mm-hmm.
Lucy, I think you were going to say something.
I'm not hearing Lucy.
Not able to hear him. Okay.
All right. Well, with that, I'm going to go on to hopefully Jimmy has audio.
Can you hear me, Allie?
Oh, there you are, Musier. Go ahead. And go ahead if
Sorry,
you
I
have
was
an
muted.
answer.
No, I was going to add, because this is really a bi-directional. I guess you are attendant, but on the same time, if you see things that you are not able to estimate calculation, if you can give us, we can add to this document, because like Tim said and Lucy, this is open for everybody because it's a common denominator for all of us across other industry, how to estimate that calculation. So if you have any hardware that you haven't struggled, I think if you can provide that to us, that'll be good for us.
Yeah, and to that end, from a previous webinar, we had many folks that requested one of those examples, like for a jacketed cable assembly or wire, as well as an assembly. So you definitely listen to that feedback, and that's why we're working on that for our next version of the document.
And one of the things to keep in mind, this is Valerie, as you continue to collect the data, I mean, obviously the as delivered is the most important piece of it, but they're also looking at what is necessary for in-process chemicals or substances that you need to be collecting, because that may impact your ability to respond or even provide the product to your client. So that's one of the reasons why ADD DSL is out there with the additional substances, is they're trying to make sure that you are able to provide the product to them in the first place. So, you know, the information that you're providing as delivered is important, but collecting that in-process information, which is what they're also trying to collect, is to confirm that you don't have to have any of these substances that may be restricted for some reason, you know, regardless of whatever the reason is. And we know going through COVID, we know that there was a whole bunch of issues that happened that you need to at least have that understanding of, for your product, can I even deliver this to my client because these products are not available? And that's what they're looking for as part of the, you know, trying to do the data collection of, you know, even if it's not as delivered, if the passivation or something else impacts it, great. And that this is the as delivered product and we have that information. However, in order for you to make that in the first place, is that an issue for you? And that's where the in-process substances and chemicals come into play.
Thank you. And with that, I'm going to ask a question that just came in the Q&A. How do you calculate substances concentration in case of passivation? And this question is for Rick Shanks.
Okay, hi. That's an excellent question that's been debated for a long time from a lot of different areas. Passivation essentially changes the surface of the steel to provide corrosion protection. There are chromates used in the solution to assist that in some of the solutions. The question really comes, does the chromate remain in the protective layer on the steel? The only real way to answer that is from analysis, but it is sufficient to say that there is a very small amount, if any, of chromates left in the chromium compounds left in the coating. So calculation-wise, it's difficult to do from taking a substance that's used in the process and other residual amounts on the surface itself. So the really only answer for that is by analysis, but the convention really has been that some amount is generally claimed to be present, but a very, very small amount, and there's no clear way to do that without some chemical analysis. Anybody else have a comment?
Thanks, Rick. Looks like, yeah, that, anybody else have anything to add to what Rick said? Okay, thank you, Rick. I'm going to go to the next question. How should we consider substances that are intended to be process only, but may be present in trace amounts on the delivered part?
Okay, I can go ahead and start that one.
Easy.
Yep. If you happen to be declaring for something that, let's say, has a reporting threshold, like REACH, for example, if something falls well below the threshold, of course, you're not required to declare that. But in either case, even if there isn't a threshold, if you're aware that something is remaining on the product, it's always, just good practice to declare kind of worst case, just declare it. If you suspect it could be there, it's always better to declare it than just to not say anything at all if you suspect that something's actually on the delivered product. Folks, welcome to add to that if you have anything else.
This is Tim. I would just, echo again, it depends upon the requirement. If there's a requirement to report those trace contaminants and that they're there, then you would report them. If there's no requirement to do so, below some reporting threshold that's been established, then and you don't know that they're there, then you're just speculating, and you may not want to have to report them.
Yeah, and I'm only going to add on to that. Usually the approach is to deal with the worst case. So if there is the possibility of the substances to be on the product above threshold, even if whatever you end up producing does not go above threshold, if there's a possibility of it, then at least communicate it, because you have, it's part of the communication requirement. So if it's above threshold, regardless of whatever the regulation is, or whatever your supplier customer is looking at, it's important to at least communicate that you think it might be there, even if you don't think it's going to be resultant there. So at least communicate that you have it, or you think you have it, above threshold, even if it's not always above threshold. If at any point it is, then that's the point. It's worst case.
Okay, great. We have a couple questions in the Q&A. I want to stick with what we're talking about and ask the question, how to calculate substance percentage in case of anodizing?
So that's a great question. Oop, I'm hearing echo. There we go. I'm actually going to refer you to the great document we've been talking about, because in the appendix where we calculate some substance masses, we did deal with an example for a sodium dichromate sealing solution. So when it comes to anodizing, there's obviously different chemistries or ways to seal the layer. So whether you're dealing with nickel acetate or a hot water seal or sodium dichromate, either way, you can follow the example where we illustrated for a sodium dichromate example, since, of course, you'd have to worry about declaring, the dichromate portion of the seal. So not sure if that answered the question, or if anybody wants to add.
It's Rick. It's a similar discussion that it was with passivation
Yep.
in the actual anodized layer as well. The chromic acid anodize is the vehicle by which you put a hydroxide on the surface, but there will be some amounts of chromium remaining.
Great, thank you. All right. If there's no further comments about that question, I'm going to go to one other question. Any plans to connect, and this question's for Monsieur Pietros, any plans to connect with the International Material Data System, which is IMDS, to standardize substance reporting?
Hey, Ali, can you hear me?
Yes.
All right.
Yes, we can.
We opted, I guess, the AD industry to go through a standard development, not a centralized IMDS structure. IMDS is really for the automotive industry and their supply chain. And what they've done is really constructed so everybody can join and really exchange the data through the data system. But we chose, because of the business to business interaction, we created we participate in the standard development, the IP754, and we have also an equivalent tool that we created for people that don't have savvy ERP PLM system, which is a Excel base, and that's called ADSRT, Substance Report Tool. So that's the path we took, because we let the each of the member company to take their own initiative to do a business-to-business contractual agreement with their respective suppliers. Anybody want to add? I think please do.
So this is Valerie, and one of the additional things to point out is because these companies are having to be so restrictive as far as who they share their information with and et cetera, the IMDS database is not helpful in order to keep that confidentiality that is necessary. And that is one of the reasons why the aerospace and defense industry has not gone down that path, because they want to keep their information confidential, but they also have to keep their information confidential based on whatever industry or country that they're working with. So an IMDS approach would not be helpful for them to keep that confidentiality. So that's one of the reasons why they're not doing it. So the 1754, anything else that they come out with, the ADSRT, at least allows them to say, these are the substances that we care about. It is separate from GADSL, but it is one of the reasons why they keep it as a separate response to their suppliers.
And I think there is one thing that I want to add on that too. IMDS, I mean, it has a cost associated with it. I don't think the AD industry, I think they probably look at it, who's going to burn that cost. It is pretty expensive to have that kind of data system. So that's another thing that I feel like, and you have also what you said, the confidentiality, but each of the member company, they can take their own, doing the contract agreement with their respective supplier. That's really give having that standard to be ability, each of us can go on our own really to get the exchange, but we have a common way of doing it. So, but the cost is another thing too.
Okay, great. I think we only have time for one more question. And I wanted to ask a question for Jimmy. Jimmy, I'm not sure if you are able to, we've had a couple technical issues. So I'm going to go on to a different question that maybe we can answer in the next couple minutes. And I don't think we have any more Q&A questions. Sorry. Okay, are there, Marcia, you can also answer this question. Are there standard declaration templates or formats to be used, or maybe examples available? I think this is a good segue.
The standard that is available for us for the AD industry is the IP754. And that's, we kind of create a tool within the Excel platform that is compatible to it. The only thing, the difference is whenever you use that Excel file, you need a conversion that you need to convert to an XML data output that the IP754 recommend. So that's only different, but all that information is actually in our AIG website. So you guys can look at it at the ADSRT and pull down. But the standard is available for the AD industry right now that is developed with the participation of the AD is the IP754, which is in the family of the IP754 175X family. So anything anybody want to add, Rick, Tim?
I think we only have a couple minutes and we have one more slide to go over. The system will shut down at the top of the hour. So with that, thank you, Musier, so much, and all of our panelists. We'd like to thank you for your time in reviewing this webinar. We want to make this a truly valuable resource for the aerospace and defense supply chain and anybody outside of it. So You can find this training and other valuable resources. We post them on YouTube. This video will be made available to you. I will also be emailing out all of our slides. Your feedback is very valuable. So we will let you know in a further communication. We'll give you the slides and let you know where to find the webinar recording. Thank you so much for sharing with us, everyone. And thank you, Lucy.